Hi, so in this video, I'm going to talk to those of you that have Secondary Math 2. This is the very first unit that you need to complete. We're going to talk in this video about the first few quizzes. It's really a lot of definitions, and they all kind of connect together. So this is the introduction to proof and logic, we're going to talk about the difference between inductive and deductive reasoning here at the very beginning. So inductive reasoning is when you take the time to make observations about the world around you and make a prediction about it. So I predict that after I sleep at night, the sun is going to rise up in the morning. As I wake up, the sun comes up. That's an observation that I make, and so it's an induction. It could also be every time I eat strawberries, my throat gets itchy, so I'm allergic to them. I'm going to induce that I have an allergy to strawberries. I don't really, but that would be an example of something. So it's when you create rules or ideas about your life experiences and observations that you are able to make. Okay, and that can lead us to a conjecture or an educated guess. In math, obviously, you're probably not going to make an educated guess about your allergies. You're going to take patterns and turn them into ideas and continue those patterns forward. For example, I have here 2 dots connected create a line. 3 dots connected are a triangle. 4 dots are a rectangle. And so then we're going to move into the 5 dots, and that will create a pentagon. So we're going to have those different, that would be one example. So you're going to find patterns, and that allows you to make a conjecture or this educated guess based off of the patterns that you find there. Okay, it's important to know that inductions cannot be proven, or conjectures cannot be proven by inductions. Sorry. So if you make an educated guess about your allergies to strawberries, and you're like, well, every time I eat strawberries, I get a scratchy throat, so I must be allergic to strawberries. That can't be proven simply by your observations. To prove it, you would have to go to the doctor and get allergy tested for strawberries, or you'd have to put forth like a more formal method for testing that conjecture. And that's where deduction comes into play. So a deduction or deductive reasoning is when you are given a set of rules or ideas that you are able to determine what is true. Okay, so I've added to our definitions or our words, our vocabulary, conditional statements. So just again, induction or conjectures cannot be proved by induction. They can't be proven simply by observing the world around us. You actually have to run, in science, you'd run an experiment to test your conjecture or your theory. In math, we use deductive reasoning to determine that something is true. So we take rules that we have been given and we run them through against our conjecture to see that it is true. Okay, conditional statements are used to word our conjecture. So if A happens, then B happens. So I'd say, if I eat strawberries, then my throat gets itchy. And so there's my conditional statement based around my strawberries or my supposed allergy. Okay, it could also be, if the sun is shining, then it's not raining outside. You could say, if I overdraw on my bank account, then I get charged a fee. Okay, these are all conditional statements. If A happens, then B happens. So you need one preceding action, and it's followed by another one, and they come in a pair. If one happens, then the other one is a consequence of that action. Right. Okay, so if A, then B happens, that is written. We commonly write that A, and you get this like double arrow, kind of the line part, the linear part is doubled up. So if A, then B. It's written often like that. Okay, conditional statements can be written in a variety of different ways. We can change the order, and the first way that I want to talk about is converse. So we can take the converse of our conditional statement. It's spelled just like the shoes, Converse shoes, okay? So the converse of a conditional statement changes the order. So rather than A being the preceding action, it's now B. So if B, then A. And we would just change this order so it becomes B, my chunky arrow, A. I don't actually know if that has a formal name or not, so we're going to call it chunky arrow. Okay, B, if B, then A. That is how we would write that. So we're just going to switch the order. So if my throat is itchy, then I ate some strawberries. Okay, that's kind of brings us to, so up here, if I eat strawberries, then my throat itches. Okay, that's something that happens. And so I say, okay, that happens every time. There's my conditional statement. Now, if I change it, if my throat is itchy, then I ate some strawberries. Is that always true? Probably not. Maybe I have another allergy. Perhaps I have an allergy to walnuts or something, and so they cause my throat to also be itchy. So I don't know the converse. In other words, the converse is not always true. Even if this one is always true, if every time I eat strawberries I have an itchy throat, it's not always true that every time I have an itchy throat is because I ate strawberries. It could be for another reason. Maybe it's allergies. It's the outdoor allergies, right? Pollen or something, or maybe I'm sick. Maybe I have the coronavirus. Oh! And maybe it's something else that's causing the itchy throat. So that's an example of converse, and just remember that just because the conditional statement is true does not mean the converse is always true. In fact, they're often not. Oh, here's an example of one. You will see this in your quiz, and I hate it. So I'm going to point it out to you because it's ridiculous. Okay, they give you this statement. It goes something like this. If it's my birthday, then it's snowing. And they're asking you to find the converse of it. First of all, the original statement isn't even true. I mean, that makes no sense. Just because it's a birthday does not mean it's snowing outside. But anyhow, on that question, if you get it on your quiz, which most of you will, again, it says, if it's snowing, then it's my birthday. The converse of that would be, if it's snowing, then it's my birthday. So you're just going to change the order. They're just trying to be tricky and give you something that makes no sense to see if you can switch that order, flip it around. So just remember, you got to replace the birthday and the snowing and swap those. Okay. Okay, so I've rewritten the board so we can kind of summarize what we have here. So conditional statements, if A, then B. If I eat strawberries, then my throat gets itchy. Converse statements rearrange the order of those events. So if B, then A. If my throat is itchy, then I ate strawberries. Inverse statements negate both of them. So they keep the original order, but they negate them. So we're going to throw in a not. If I don't eat strawberries, then my throat isn't itchy. Okay, so if not A, in Apex, the not is written like that. I don't know why, but there we go. If not A, then not B. That is the inverse of it. So we kept the original order, but we made them both statements negatives of them. So what's another example? If I don't overdraw on my bank account, then I am not charged a fee, right? There's a real life example for you. Okay, contrapositive would be another version. This one's fun. Contrapositive. Okay, so contrapositive takes both the converse and the inverse and kind of combines them into one. It's a 2-for-1 deal. So we're going to switch the order of events. We're going to have B, and then A, but we will also negate them. Okay, so if not B, then not A. So if my throat is not itchy, then I did not eat strawberries. If I am not charged a fee, then I did not overdraw my bank account. So the interesting thing, if we take an original statement, if I overdraw my bank account, or if I overdraw, then I'm charged a fee, and I switch that, if I'm charged a fee, then I overdrew. That may not be true. Perhaps I'm charged a fee for something else. So the converse is not always true. We are going to take the original as always true. If it's given to you, if you're told if A then B, then we're going to accept that this is true. Then the converse is not always true. The inverse is often true. That's fine. So if I don't overdraw my bank account, then I'm not charged a fee. If I don't eat strawberries, then my throat does not itch. The contrapositive is also true. So if I am not charged a fee, then I did not overdraw. If my throat does not itch, then I did not eat strawberries. Okay, so those are all true statements. They're all ways to take a conditional statement and think through that. Another conditional statement is called a syllogism, or they call it a syllogism. Let me make sure I spell this correctly. Okay, syllogism. So interesting, in college, I swear we called it the transitive property or a transitive statement. And we've talked about transitive in math with other statements, so it's interesting that Apex calls it syllogism, but that's fine. Here's our new word. Okay, this takes two statements and connects them into a third. So if we are given, if we have if A, then B, and if B, then C, whoops, that's not C, that's A. Okay, so if A, then B, and we're given if B, then C, then we can say that A can skip right through B to C. So we get if A, then C. I like to think of this one kind of like a bus route. If I get on the bus in Vernal, and that bus travels to Fort Duchesne, and the bus from Fort Duchesne travels to Roosevelt, then the bus from Vernal will travel to Roosevelt. So it's like bus stops, right? If I start in Vernal, or if there's a bus stop in Vernal that goes to Fort Duchesne, and then the bus stop in Fort Duchesne goes to Roosevelt, then the bus stop in Vernal also goes to Roosevelt. So it's kind of like a little pit stop along the way, but it gets us there. So that's syllogism. This is, these are all your vocabulary that you need to know for your first few quizzes. Your questions, again, some of them will be ridiculous, like if it's my birthday, then it's snowing. What's the converse? If it's snowing, then it's my birthday. The inverse of that would be if it's not my birthday, then it's not snowing. So they have some really goofy examples. Just remember, you got to switch the order, negate them. Contrapositive combines them in two, and a syllogism takes three if-then statements to kind of connect them, or two if-then statements to connect them into the last one, so you get three if-then statements. Okay, I wish you the best of luck on this quiz. Let me know if you have any further questions on it.